Hello guys, today I'm going to use this video to explain this worksheet that I gave you 2 days ago, the bond energy. I hope you have already tried it. Once again, if you haven't tried it, then do not watch the video, try it again, okay? So, let's go to, I will go through all the questions with you, okay? As a revision for this topic. Now, okay, what is the order of enthalpy change of this reaction from most negative to positive? Okay, so we have to work out the enthalpy change of P, Q, R, S respectively. Then we can rank them. Okay, from most negative to most positive. Now for P, the BRBR is broken down into two bromine atoms, right? So for on the positive side, they are not going to form any new bonds. They are separate, the two bromine atoms. So you just have to consider the bond breaking. If you remember, the bond breaking in chemistry is positive. I'm talking about the enthalpy change, okay? And the bond forming is negative, right? It's very easy to understand because you require energy to break down the bond, okay? So for P, we will look at this data. If you have to break this bond, you need 193. Since this is a bond breaking process, so it is positive 193, okay? Now for this one, it's the reverse of P, right? Because two chlorine atom, they are going to form a new bond to become a chlorine molecule. So this will be this one, right? But instead of positive value, this is negative 244, right? And for R, if you compare the reactant and the product side, obviously originally is CH3, right? And then when they come together, they're going to form a new bond, okay? A new bond. So a new bond CCl is formed, so it's here. Since it is bond forming, is negative 340, okay? And this one is different. Basically, you need to break down this bond so that they become this one, right? So since you are breaking a CH bond, so it is positive 410. Now after getting these four datas, you can prioritize them from most negative to most positive. So I bet the most negative one is this one, then this one, then this one, then this one, right? So it should be R, Q, P, and S, okay? So let's look at the option. So it should be C. Understand? Understand? Okay, let's continue. Okay, which process could be used to calculate the bond energy of the covalent bond CY by dividing its delta H by N? Wow, the answer is very obvious. This is A. Now, you can consider this as methane, right? Methane, if you have to break it down into this one and this one, right? Then the delta H, okay? Now for this one, you have this one, right? If you have to turn it to positive side, you are breaking down 4 CH bond, right? Breaking down 4 CH bond, right? So basically, the delta H is 4 times the bond enthalpy of CH, right? So if you have to find the bond enthalpy, you have to divide the delta H by 4, right? So when you try to put this example into A, it's exactly the same. It's just this X is the carbon and the Y is the H and N is 4. So basically, the CY bond will be equal to the delta H over N. Do you understand? Okay? 好, let's go to this one. This one is easy. So basically, you have this one and this one, right? And after forming the product, you have this one and this one. Okay? Now, if you still remember, there is an equation we learned in IGCSE that is the energy of bond breaking minus the energy of bond forming, right? So in order to turn the reactant to ported, we will look at what kind of bond do we need to break. Okay, do we need to break? So basically you have to break down the double bond and you have to break down the HF. Do you agree? So the bond breaking will be, you need to break down a double bond and you need to break down a HF bond, right? And then this is an addition reaction. So, okay, and the double bond after breaking down, they have to form a single bond back, okay? So the bond forming, I bet you have to form a new CH bond, a new CF bond, okay, here, these two bonds, CH-CF, and you have to form a new CC bond because you break down the double bond. You need to form the single bond back, okay, here, okay? So, then we substitute the number for bond breaking. You need to refer to your booklet, okay? I don't have a booklet here. So, okay, let me see how much time I left. Okay, I think I have enough time to find the booklet. Oh, it's here. Okay, so we look at here. Now we need a HF lah. We need HF, right? Yeah. It's running out of time. Oh, freak. Okay, so we need a CC double bond, right? CC double bond is here, 610, right? So we need a CC double bond 610, like bond breaking 610, and we need to break down a HF bond. HF bond is here, the first one, okay? The right hand side, the top one, 562. Okay, then we work out this number. So it's 1172. Okay, and then the bond forming will be, we need to form a CH bond. CH bond is here, 410. And we need to find what? Oh, we need to find the CF bond. So the CF bond is an unknown. And as I said, we need to form a CC bond, right? We need to form a CC bond. Can you see that? CC bond as well. So we need to 350, right? So bond breaking minus bond forming may be equal to delta H. The delta H should be given is negative 73. So it will be negative 73 bond breaking minus bond forming. Okay, I sum this number together. Okay, so therefore the CF will be positive 485 kJ per mole. Now remember the bond energy. Why? Remember the bond energy is always positive 485, always positive, because bond energy means the energy required to break 1 mole of that particular bond. Okay, so the answer, the final answer is negative 485. Okay, so remember to get your data booklet, okay, ready when you're doing this. Okay, now I will make another video to explain another worksheet. If you remember, I gave you 2 sets of worksheets about the enthalpy, about the bond energy. This one is the first one. Okay, hope I will get back to you later. See you. Work hard.